So let's just recap what we achieved in the last post. So in the last post, we were looking at the processes folder here, and we discussed about the RFM maker, wherein which was talking about the processes of segmenting the customers into the 4 segments, which we finally made. Now we'll go ahead from there and then look at the next processes, which is the RL learn and RL recommend. Now RL learn is about using the data to create those value and reward dictionaries, and RL recommend is to recommend products. Now we have seen all these things during the prototyping phase in post 5, so please refer to that also. So let's get going. So the files which we want is, so you have to create a new file called the self-learn process.py. So just as usual, create a new file and name that self-learn process.py. Let me open that because I have already made that. So learn the self-learn process.py, and then let's start exploring this. So as usual, we from line 8 to 14 we import all those necessary packages which we require for this. Now 15 to 17 onwards, it's we are making a small deviation from what we did in the prototyping phase. Now in the prototyping phase we were storing all those values in dictionaries, but when you get into a real application, maybe we will have to store values in some database. So here we are using the MongoDB as the database, and PyMongo is an API Python wrapper for connecting to MongoDB. So there are different good tutorials on PyMongo and MongoDB. So I've listed that in the blog post, so you can refer to one of those posts. So but we will also explain this on the way when we look at different cases. No, so the line 15 is about importing the Mongo client. So Mongo client is something which connects to the MongoDB database. So, and line 16 is where we really create the connections. So the port is by default is in a port called 27017. So we create an instance of the client, and using the client we connect to the database. So the client, the line 17, the RL recommendation is the name of the collections which we are using. And so in MongoDB many records are called the collections. So you can change this name to anything which you want. So currently we are our collection where we are storing all the recommendations and all the data is called RL recommendation. So this is something which you can change. Client will remain because this is the client is the actual connection. And finally the DB is the whole instance of this collection. So we will be working on DB from now on. So these are the import part of it, where the major difference is on the Mongo client. Now let's look at the RL learn class. So RL learn class is about creating the data required for initializing the value functions or value distributions and the reward distributions, and all the other dictionaries which we have seen in post 5 during the prototyping phase. So the constructor, the inputs are your customer details. The customer details is something which we created in the last post, and the configuration file. So these are so you have your configuration file here, and the customer details we have already created. So now the first line 24, 26 and 28 we have seen that in the post. So here we are again creating a new variable called date, wherein we use a past date variables, and then we extract the days, the days in the month, so here the input or the variables will be in the form of 1 to 30 of each month, or 1 to 31 as the case may be. So why we are extracting is because we are creating the month period. We said that in the states, in when we define the states, one of the state is the days before 15th and after 15th. So that's why we are creating this month period. And finally we are creating this data frame wherein we are grouping the whole data in according to the segment, month period and day, and then consolidating the products according to the quantity. So we are consolidating and aggregating the sum of all the quantities according to the different components of a state. So these are the components of a states, and then we are aggregating in this data. So please refer to post 5 also. You will have the complete explanation there. And then the customer details we have and all the configuration file and all these other reward full, all these variables we are storing as self dot, so that it is available for across all the methods. And then we also create all this dictionaries here, the count dictionary, policy dictionary, reward dictionary, and the recommendation count dictionaries. All these dictionaries are where we store these values, and then after this we'll see that how we insert that into MongoDB. So that's the constructor part. Now let's look at the main method, which is the product consolidator. This is where we consolidate all those data. So the first part is to get the unique values of the segments, months, month period and days. We use this function, this unique words, which is this function, wherein we are only taking the unique values of each of those things. And then once you get all those unique values, we create 4 different inner loops. First we loop through the segments, then the months, then the periods and the days, and then we get a and first we take a subset of the data according to the state ID. The state ID, as you know, is a combination of all these things, where segment, month period and day. So for each state we are getting the data, and then we are creating a temporary dictionary. Why we are creating this temporary dictionaries is to store the data in MongoDB as separate records. So each state ID and its relevant data would be stored as a separate record altogether. So that's the way we want to. So that's why we have this temp dictionary. So then as usual, so once the subset of data is there, if it is more than 0, we extract the state IDs, the ID of the state, which is the combination of the segment, month, period and the day. All these components which we are talking about, and then and we create a inner dictionary for the count dictionary. One is the count dictionary and the temp dictionary. Why do we have to create 2 separate ones? We'll see later that count dictionary, again we use it for creating other dictionaries like the rewards and the recommendation counts. And temp dictionary is usually to insert in MongoDB. That's what we will use for. Okay, so we iterate through all those different products in this subset, subset.stock code. Now all these products are within each of the stock code, which is the product code, and then we store the values, the values of or the quantities of the subset as the values in the inner dictionary. So the key of the inner dictionary is the stock code, and the values is the quantity. So just go through the pause this video and then observe this again. And the similar way we even the temp dictionary also we created the same way. And then once all the for that particular subset, all the products have been covered, we insert that into MongoDB using this. So db.rlquantdic.insert tempdic. So this is where we dump this data into MongoDB as one record. So according to each state, we have all these records or all the data for one state ID. We dump all this record, and here rlquantdic is a specific name of the collection for the quantity dic. So inside the RL recommendation, which is the overall database, inside that this will be a collection called rlquantdic. That's how MongoDB works. We have individual collections inside that, and so that's the database, and inside the database rlquantdic is the collection. So we store this data. Now here I told that we use the count dictionaries also to create the other rewards and value functions. So now we again iterate through the through each of those keys. The key here is the state ID. So for the count dictionary, the keys are the state IDs. So we go through each of the state ID. Again, we create these temporary dictionaries for the policy and the reward. And this is again to store load these values or dump these values in as specific state ID wise records in MongoDB. That's why we create these temporary dictionaries. And then first we get all the product counts, the number of products which are there. For that specific state ID we get all the product counts, and again we create this inner dictionaries for each of the state IDs. We create a inner dictionary for policy dictionary and reward dictionary, and the same with inner dictionaries for temporary dictionary, temporary policy dictionary and temporary reward dictionaries. So these temporary dictionaries, always remember, it is for dumping into the MongoDB. So again we are going through each of this product key. Product key, P key is a product key. We have we are going through each of those products, and then what we have seen in post 5, each of those the quantities, based on the quantities, we are creating a Gaussian distributions to get the policy dictionary and the reward dictionaries. Again, Gaussian as a Gaussian distribution, we generate this for each of these products, for each of the states. So that's how it is. And then once for each state is complete, we keep on inserting that values in MongoDB. So that's the way we are doing. So RL reward dic is the name of the collection for the reward dictionary, and RL value dic is the name of the for the temporary dictionary. So this ends the complete the product consolidator. So here we are creating all those value dictionaries from the data which we have.